If I was to ask you, what is a drought? I'm sure you'd be able to give me an answer. However, if I was instead to ask you, what is a pluvial, would you be able to tell me? A pluvial is essentially the opposite of a drought, defined by a period of above normal precipitation, and yet it does not get as much attention. The impacts from pluvial periods can include flooding, although not all pluvial periods do, and usually the impacts tend to be beneficial to society. Normally we, as the human race, tend to focus on the negatives of natural phenomena. Therefore, pluvials tend to not get as much attention as droughts.
So how do they work? The mechanisms which cause an individual pluvial event can be complicated and vary from event to event. Essentially, for a pluvial to occur in a region, there needs to be a surplus of moisture in the atmosphere. One way for this to occur is through warmer sea surface temperatures. Warmer sea surfaces lead to higher evaporation rates, which in turn can create moisture surplus over the ocean. This moisture excess can then be advected over a region continuously, creating a pluvial event. Even so, oceanic drivers alone cannot explain the intensity of pluvial periods. Hence, atmospheric drivers must also be important, and these atmospheric drivers vary from region to region. Convergence of moisture through atmospheric processes is an important driver of pluvial periods. This convergence of moisture leads to high precipitable water anomalies over a region, which is defined by the amount of rain that would occur if the water vapour in a column was to condense out and be measured at the ground. The higher the precipitable water anomalies, the higher the amount of rainfall that will occur in that region, leading to a pluvial event. Pluvials can play an important role in societal development and can have a large impact on history. Two pluvials in the 19th century led to the migration of people to central and western portions of the United States. But one of the more notable impacts that the pluvials had on history involves the Mongolian Empire. In the late 12th and early 13th centuries, Mongolia was affected by a significant drought, which created political instability in the region. Genghis Khan, who was the first great Khan of the Mongol Empire, capitalized on the political instability and became the unified leader of the Mongol Empire by 1206. However, a tree ring study of Mongolia showed a 15-year pluvial starting in 1211 and ending in 1226. The pluvial aided in grassland production in the region, leading to an abundance of resources. And with the extra resources, the Mongol military was able to mobilize and take over the world, literally. Now the big question is, how should we expect pluvials to change with changing climate? As the global temperature increases, our atmosphere will be able to hold more water vapour, which suggests that we should see more rainfall events, and possibly those rainfall events being more intense. However, it's not quite that simple. Regions that are already considered climatologically wetter are expected to see an increase in the intensity of pluvial periods, whereas the areas that are considered to be climatologically drier are expected to get drier, and will hence see their frequency and intensity of pluvial periods decrease. The United States has seen an increased frequency of pluvials since the 1970s, with 3 large pluvials having occurred in the past 30 years. All in all, how the frequency and intensity of pluvials are expected to change depends on our behaviour and reaction to the changing climate. If we continue on business as usual, then the magnitude of pluvial periods will increase greatly. We could see rainfall in some regions of the US increasing by up to 36%. However, if we begin to mitigate and take action against our changing climate, then the frequency and intensity of the pluvial periods we experience will likely be reduced.